What we're going to start talking about now are rational expressions. And rational expressions are fractions on steroids. Fractions on steroids. A rational expression has variables in the denominator. And so we are going to start with simplifying them, and then we're going to move on to multiplying and dividing them. When you get stuck, what you want to do is you want to think about what would you do with a fraction. That's what you do when you get stuck. What would you do with a fraction? So here we are. We've got 18 over 24. Now, likely what you would do if you were given 18 over 24 is you would say, okay, what number goes into 18 and 24? 6. So we would say 18 divided by 6 is 3. And 24 divided by 6 is 4. And so the answer to that right there is 3/4. However, I want you to think about it in a different way. I want you to think about it in a different way. We are going to do something called prime factorization. So we are going to break everything down to primes. Okay? Do you remember the factor tree? Remember the factor tree? So if I have the number 18, I need two numbers that multiply together to give me 18. 6 and? Good. Now, could I have written down 2 and 9? Yes. It didn't matter which ones I did. 3 is prime. That means it can't be broken down anymore. Okay, there's no two numbers that I multiply together to get 3 except 1 and 3. But 6 can be broken down again. What can 6 be broken down to? 3 and 2. Okay, so 3 times 2 times 3 is 18. 3 times 2 times 3 is 18. That is the prime factorization of 18. And that's what I want you to get in the habit of doing with these types of problems. We are going to break it down as far as we can break it down. Now, let's do that again with our denominator. My denominator is 24. What does 24 break down to? 6 and 4. I could have said 8 and 3. I could have said 2 and 12. Okay? 6 breaks down again. And 4 breaks down again. You go as far as you can go. As far as you can go. I like to write them in numerical order after that. That's a good habit to get into, but it's not imperative. It's a decent habit. Then what we're going to do is we are going to cancel out anything that's on the top and the bottom. Okay? Anything that's on the top and the bottom. Okay? What number do I have on the top and the bottom? 2 and 3. So I'm going to factor it out. 2 and 3. Okay? I've got a set of 2's and a set of 3's. Then I'm left with 3 over 2 times 2. What happens in this situation is students typically do okay with the numbers, but if they don't write it out this way, they don't do okay with the variables. Very often I have students that will simplify the numbers correctly, and then they've just left all the variables. Okay? And so we don't, so when we break it down like this, it gives us a more algebraic approach to it. Okay? Now, we're going to break down negative 36. The first thing that we're going to take out of negative 36 is the negative 1. Okay? So negative 1 times 36, that's the first thing that we're going to take out. Then I can break 36 down to 6 and 6. I could say 12 times 3. I could say 9 times 4. Any of those are completely fine because I'm going to get to the same place. 6 breaks down to 2 times 3. And that is my prime factorization. -1 times 2 times 3 times 2 times 3. Okay? I like to put them in order, numerical order. Okay? Okay, let's break 63 down. 63. What two numbers multiply to give me 63? 9 and 7. Good job. 9 and 7. Okay. 9 breaks down again. What does 9 break down to? 3 and 3. Okay, so then I have 3 times 3 times 7. Okay, and you may not need to do the factor tree every time, but that's what we do when we have some of the larger numbers. For our next one, we're probably not going to need the factor tree. If it's on the top and the bottom, I cancel it. For this one, I'm left with -1 times 2 times 2. So I'm left with -4, and then what am I left with on the bottom? 7. Okay. 15 times x times y. Now we're going to move into variables. So we've gone from simplifying fractions to now we are simplifying rationals. We're going to do it the same way. I want you to write it all the way out. You may not need to do 15. Question?
So, I have a question about, like, okay, since there's a y already on both ends, could you just cancel it out right now? Or
You
no?
could, and we kind of have a more simple one. And so I would go ahead and write it all out so that you can see how the simple one works. So yes, the y and the y cancel. You're absolutely correct. But I want to make sure you catch everything when we've got things that are squared and cubed and stuff like that. But you are correct because we've got a y on the top and a y on the bottom. It cancels. Okay? Who can tell me what 15 breaks down to?
5 and 3.
Good. Okay? And I'm going to write it as 3 times 5 because I like to write mine in order. Then I'm going to write x times y. Now, if I'd had y squared, I would have written out y times y. Okay? Because it's a good visual and it helps us. Now, 25. What does 25 break down to? 5 and 5. Then I've got a y. Okay? And the y's cancel. Okay? And then one of the 5's cancel. So what am I left with on top?
3 times x over 5.
You are correct. 3 times x over 5. And again, students sometimes just focus on the numbers and then they don't want to know what to do with the variables. Especially once we start having variables that are squared and cubed and risen to higher powers. Okay? Now, we're going to start with -28. What did I tell you was the first thing we take out of -28? Good. Okay, and then 28 breaks down to? It's even, so what do we know goes into it?
9 and 3.
Okay, it's not 9 and 3. It's even, so we know 2 goes into it, right? Anytime you got it is 7 and 4. But anytime you've got an even number, you know that you can divide by 2. So what's 28 divided by 2?
14.
Good. Now, I had somebody say, what about 4 and 7? And absolutely. 4 and 7 is usually what we think about with 28. But if we were stuck and we couldn't remember that 7, divide by 2 because it's even. Okay, so for my 28, I've got -1 times 2 times 2 times 7. I am going to write out these variables. A squared means A times A. B squared means B times B. And I'm going to write all of that over my negative 63. Now, what do I take out of the negative 63 first? Okay, and we've already done 63, so you might not have needed to do it again. What is 63? Good. 9 and 7, and then we have 3 and 3. So negative 63 is negative 1 times 3 times 3 times 7. Then I have A squared. That's A times A. And then I have B times B times B. Okay? I would encourage you to write it out. My negative 1s cancel. What else cancels? What is another number that cancels? Good. Okay, I have an A and an A. I have another A and another A. I have a B and a B and a B and a B. Now, don't lose that B right there. It's dangerous. Sometimes students forget that B. Then I've got 2 times 2 and 3 times 3. So I have 4 over 9. And does that B go in the numerator or the denominator? Good. Okay, that's the bottom. You're going to keep it in the bottom. Okay, what was last chapter about? What did we do last chapter? Factoring. Factoring. We are going to use factoring all the time in this chapter, okay? We're going to use factoring. So if you didn't love your test score from Wednesday, you need to practice factoring, okay? And I can give you some things to help you, but you need to either email me or come and see me so that I can give you some practice, okay? Now, here we've moved to binomials and trinomials. That means we've got some pluses and we've got some minuses. You are always going to factor first. Always. You have to factor first. Okay? Before you start canceling things, factor. Okay? So I'm looking at my first one. X squared plus 4x over x squared minus 16. What's my GCF for x squared plus 4x? What comes out of both of those? Good. Okay. Now, x squared minus 16 is special. Okay? How does x squared minus 16 factor? Excellent. X plus 4, x minus 4. Or did I make a mistake? No, am I good? Okay. That's the difference of perfect squares. Now, okay, now, don't go factor crazy, okay? Students like to factor this x, and you can't do that, okay? This is the factor right here. You've got to factor it as a unit. You can't cancel just parts of it, okay? So my answer here is x over x minus 4. Okay? Now, I'm going to give you about a minute to factor these two. I want you to factor 6a squared minus 7a plus 2. And then I want you to factor 10a minus 15a squared. Okay? So you are factoring both of those right now. Okay, a refresher for factoring. I take 6 times 2 to get my product. What is that?
12.
Good. That's my product. What's my sum? Good. So I have a product that's positive and a sum that's negative. What can you tell me about my two numbers? They're not going to be opposite sign because my product's positive. Okay, they're both negative. When you have a positive product, they both have to be negative or they both have to be positive. Okay, so don't forget that. What are my numbers? Excellent. -3 and -4. That's because -3 plus -4 give me -7. -3 times -4 give me +12. So now I split. So I've got 6a squared minus 3a minus 4a plus 12. Okay? What comes out of the first two? Did I mess up?
It should minus 12.
Oh, it's plus 2. Plus 2. I'm sorry. Plus 2. Okay. What comes out of the first two? Good. Okay. What's left? Good. Okay. Now, what comes out of the -4a plus 2? What comes out of the next two? Okay, what else? What do we take out when that third one's negative? Not just 2. -2. Anytime that third number, anytime that third term is negative, take a negative out. Okay? So I take out a -2 and I'm left with positive 2a, which is what we want, minus 1. So this factors to 3a minus 2 and 2a minus 1. Okay? So I have 3a minus 2 and 2a minus 1. Okay? Now, what comes out of 10a and -15a squared? What comes out of both of them? 5 and a. Okay, now when we do this, I get 5a times 2 minus 3a. Can I cancel anything? Can I cancel anything?
2 minus 3a on both sides, because one of them is 3a minus 2. Wait, no, you can't cancel that. I'm sorry.
Okay, why can I not cancel it? Because you're absolutely right. I can't cancel it. Can you tell me why?
Because the 2 on the bottom is positive and the 2 on the top is negative.
Absolutely. Okay, so 3a minus 2 and 2 minus 3a are very, very close, but they're not exact. So I can't cancel those. Okay? But I can do something a little bit different. Okay? Yes. Who said that? Factor out a -1. You're absolutely correct. So I'm going to go back to my factoring. I'm going to go back to my 10a. Now, what did we say came out of both? What? 5. 5 and a. What if I took out a -5a instead? Okay, so I'm going to take out a -5a. -5a times what gives me positive 10a? Not positive 2, -2. Okay, -5a times what gives me -15a squared? Okay. Now, is that the same thing? Yes. What? I'm sorry? You could have done that in the beginning, but you might not have realized you needed to. Okay? A lot of times we don't realize we need to until we get a little further on. Okay? But you absolutely could do it from the beginning if you realized you needed to. Okay? Now, That is one of the more difficult concepts to really wrap our mind around this unit. So when you practice that on classwork, you're going to see it on a quiz, you're going to see it on the chapter practice tests. Keep in mind that factoring out that negative is one of the things that's a little bit more challenging. So practice, practice, practice. Okay, so I have 2a minus 1 over negative 5a. Okay.
And this is what our homework will be like?
Yes, ma'am. Yes, ma'am. Okay, now we're going to move to multiplying and dividing. Multiplying and dividing. Okay? So, when I multiply fractions, and again, when you're not sure what to do next, think about fractions. Think about the rules of fractions. When I am multiplying and dividing fractions, do I need a common denominator? No. Now, in 3rd or 4th grade, whenever we really started doing operations with fractions, we were taught to multiply across the top and then multiply across the bottom. So I have 2 times 4 is 8. 4 times 5 is 20. And then I simplify. Okay, 4 goes into 8 twice. 4 goes into 25 times. Now, you can still do it that way, but it does make it sometimes more challenging. I want you to break it down to primes, just like we did with the simplifying. Okay? Does 2 break down? No. So I'm going to have 2 over 4. How does 4 break down? Good. Okay? Then I've got another 4. And then what do I have in the denominator? Just 5. Okay? If it's on the top and it's on the bottom, it cancels. So what am I left with here? This process helps you when you add the variables.
Wait, why is the one in the top crossed out? I mean, why is there another one in the bottom crossed out when there's only like 1, 2 at the top and 2 at the bottom?
Okay, so you're going to look at all of this. Okay, so how many 2's do I have in both tops?
Oh, we're looking at both. Okay.
Yeah.
I was only looking-
No, you're good. You're totally good. We can look at both because we're multiplying. I think you're thinking a little bit about addition.
I don't know.
You're all good. It's all good. Okay? So my final answer is to this. Okay? We're going to do it again, and we're going to add variables. 3 does not break down. So I am just left with 3 times x. Does 4 break down? Good. 2 times 2 times y. Okay? 2 times 2 times 2 is 8. So if you need to do a factor tree on 8, do it. So I have 2 times 2 times 2 times y times y. Okay? 9. What does 9 break down to? Okay, don't forget your variables. Now, if it's on the top and the bottom, it doesn't matter where it is, I can cancel. So this 3 cancels with a 3 in the other denominator. These set of 2's cancel with this set of 2's, even though they're in opposite fractions. We're multiplying, so it's allowed. Okay? I have an x here and an x here. I have a y here and a y here. So we canceled out a lot of stuff. So you want to be sure you find everything that's left. I have a 2 left right here, and I have a y left right here. So in my numerator, I have 2y that's left. In my denominator, I've got a 3 that's left. Okay? Now, we're going to use those same principles, and we're going to add binomials and trinomials to it. What do you have to do first? Factor. We're always going to factor first. Okay, so let's look at this next one. Okay, can my y factor? No, it just stays y. Now, x squared minus 4 can factor. What is it? What type of factoring problem is that? Good. So it's x. Good. X plus 2, x minus 2. Okay, now I'm going to multiply that. Can x plus 2 be broken down? Okay, and then I've got y times y. Y times y. Okay? Now, I have an x plus 2. That is a binomial factor. It's got to stay together. And I have x plus 2. Then I have a y and I have a y. What is y divided by y?
0.
No.
Why?
Y divided by y. What is it? 1. What's 3 divided by 3? 4 divided by 4. X squared divided by x squared. 1. X plus 2 divided by x plus 2. 1. So when I cancel everything out, I'm not left with 0. I'm left with 1. Okay? That's the second issue that students come up with this chapter. Is when they cancel everything out, they forget that they're left with 1. So I have 1 over x minus 2, because here's my x minus 2 right here. And here's my y.
Would you distribute?
You do not need to. It's still correct if you do distribute. You just don't have to. Van, did you have a question? Oh, I thought I heard a question over here. Oh, Michael? Question?
I figured it out.
Oh, perfect. Okay. Okay. Now, I'm going to give you an opportunity to factor again. Okay? You have 4 different things that you have to look at. And only one of them doesn't factor. Okay? Only one of them doesn't factor. Now, that x to the 4th minus x squared. So this one right here, that's a little bit challenging. Take out an x squared. Take out an x squared. So I have x squared times x squared minus 1. Okay? So take a minute or so and factor. Sometimes students struggle because now all types of factoring are in the same problem. Okay? And so they're like, okay, I know I can factor this, but I'm not sure which method to use. What do I always tell you to look for first?
GCF.
A GCF. What's my GCF in x squared minus x? Good. So I have x times x minus 1. I can't break that down any further. X plus 5 can't be broken down. Okay, x squared plus 5x plus 4. That's a trinomial, and it's not too bad. Okay, my product is 4. My sum is 5. Everything's positive. What are my numbers? 4 and 1. X plus 4, x plus 1. Okay, x squared, and I'm going to write that down as x times x. what's x squared minus 1? That factors further. What is it? X squared minus 1 is x plus 1, x minus 1. That's a difference of perfect squares. So I have x plus 1 and x minus 1. Okay? I have an x and an x minus 1 and an x minus 1, an x plus 1 and an x plus 1. Okay, I'm left with x plus 4 in the numerator, x plus 5 in the denominator, but look, don't lose that other x. Don't forget about that. Okay, you do not have to distribute it, but don't forget about it. Okay? Okay, so we've simplified. We've done multiplication. What are we going to do now? What are we going to do now?
Oh, this is the end.
This isn't the end. We got one more thing. We simplified, we multiplied, division. Okay, now think about fractions. Think about fractions.
I meant the end of that problem.
Oh, it was the end of that problem.
I was trying to take a picture.
Oh, got it. Okay,
I thought like you still.
you're good. You're good. You're good. I can't do anything else to that.
Got it.
Okay, perfect. Here we go. So, we've simplified, we've multiplied, and now we're going to do division. You always want to look at what we do when we're dividing fractions. We're going to use that same principle when we're dividing rationals. Okay? I have 7 over 8 divided by 5 over 6. What is the process when I'm dividing fractions? I keep, change, flip. Always, always, always do that first. Always. So I have 7 over 8. I change division to multiplication. And then I flip. Okay? It is still in your best interest to break this down to primes. Okay? Students make less mistakes when they break it down to primes or factor. Okay? So 7 is prime, so I can't do anything. What's 8? Okay? And 4 is 2 times 2. So is 2 times 2 times 2 8? Good. What does 6 break down to? 2 and 3. Okay. If it's on the top and the bottom, it cancels. There's not a lot that cancels there, right? What's 7 times 3?
21.
Good. 2 times 2 times 5.
20.
Good. Okay? So don't forget your keep, change, flip. You're going to do that first. You're going to do keep, change, flip first. So let's try another one. We're going to add variables. Lots of variables. Lots of squares. Some thirds. Okay? I'm going to keep, change, flip first. So I have 16x squared y over 24x y to the third. I change division to multiplication. My denominator becomes my numerator. My numerator becomes my denominator. Okay? Now I'm going to break everything down to primes. If you forgot what 16 breaks down to, that's okay. I've got 16, 4 times 4, 2 times 2. Okay? So I've got 2 times 2 times 2 times 2. I want to break the x squared down too. So I'm going to have x times y. Now, 24. You may need to do the prime factorization of 24. Okay, 24 breaks down to 6 times 4, 2 times 3, 2 times 2. Okay, how many y's do I have? 3. So I have y times y times y. Okay, we already know that 8 breaks down to 2 times 2 times 2. How many x's do I have? And how many y's do I have? Sorry. Okay, what does 9 break down to? 3 times 3. I've got an x and I've got a y. So I've got a whole bunch of stuff here. But I've broken it all down. Okay, so I can cancel some of this stuff out. Okay, a 2, a 2, a 2. Sounds like I'm sneezing. Okay. I've got an x and an x and a y and a y. Now, it does not appear that I have any more numbers that can simplify. But I do have some x's and y's that can simplify. Okay, I have an x right here. Could I cancel that with this x right here? Yeah. Okay, and then I have a y right here. Can I cancel with this y right here? Don't forget, I ran out of space. I've got a y right there, so I can cancel over here. Okay? Now, going back and making sure you find everything that you didn't cancel out is sometimes a struggle. I have a 2 right here, a 2, another 2, and a 2. Okay? What's 2 times 2 times 2? 6, and times one more. 16. Okay? And then I have x times x. What's that? Good. Now, in my denominator, I have 3 times 3 times 3. 3 times 3 times 3. Yep. Good job. Okay. Don't lose that. Do you see that? Sometimes you can lose those things. So be careful. Can I go to the next screen? Okay, I'll wait. I'll pause. Can I move? Okay, we're good? Okay, what do you think I'm going to want you to do here? What am I going to ask you to do first? We are going to factor second, and factor was a very safe guess. You are correct.
Well, the keep one.
Yes, keep, change, flip. So go ahead and do that. Some students like to factor and keep, change, flip at the same time. I'm not going to tell you you can't do that, but just be careful. Okay, there's lots of opportunities for mistakes. So I'm going to keep, change, flip. 3a squared plus 12 over 3a squared minus 15a. My division becomes multiplication. I have a squared minus 3a minus 10. A to the 4th minus 16. Now, what I want you to do right now is factor. Now, I'm just going to remind you, a to the 4th is a perfect square. A to the 4th is a perfect square. What do you multiply times itself to get a to the 4th? A squared times a squared. Good. Okay, I'm going to give you about a minute or two to factor. Okay, on the first numerator, 3a squared plus 12, the only thing you can pull out of that is a 3. Okay? The only thing you can pull out of that's a 3. What can I pull out of the bottom? A 3 and an a. Okay, so in the bottom I'm left with a minus 5, is that right?
Mm-hmm.
A minus 5. Okay? My numerator on my second problem, a product of negative 10, sum of negative 3. What are my numbers?
2.
What kind of 2 and what kind of 5?
Negative 5.
Perfect. Good job. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. Now, a to the fourth minus 16 is a little bit challenging. A to the fourth minus 16. That is a difference of perfect square because a squared times a squared gives you a to the fourth. So that factors twice. And sometimes we don't like to factor twice. Okay? So I've got a squared minus 4 times a squared plus 4, and then we stop. I can't do anything else with a squared plus 4. But a squared minus 4 is what? What is it? It's another perfect square. So then I get a plus 2 and a minus 2. Did somebody say what?
Yeah. Can you explain that one more time?
Okay. So I'm doing it up here. I wrote it down there. So I've got a to the fourth minus 16. A squared times a squared gives me a to the fourth. Negative 4 and positive 4, those are the difference of perfect squares. So the square root of 16 is 4. Okay? So we're good right here. I can't do anything else with this a squared to the fourth, so I went ahead and write it down. A squared plus 4, I'm sorry. But a squared minus 4 is another difference of perfect squares. So the square root of a squared is a. What's the square root of 4? 2. So then I've got a plus 2 and a minus 2. So you had to factor it twice. Okay, so now let's cancel some stuff out. I've got a 3 and I've got a 3. Be careful of that a in there. Don't go factor crazy and cancel that a out. I have x minus 5 and x minus 5. X plus 2 and a plus 2 and a plus 2. Then I've got a squared plus 4 and a squared plus 4. What am I left with on top? Nope, not my 3 canceled. 1. Okay. Then on the bottom, don't forget that a. You see that a right there? Don't forget it. It wants to be part of your answer. And again, you do not have to distribute that. You do not have to distribute that.